What's up, guys? Let's take a look at another CodeWars exercise. This one's called dot calculator, and I'm going to scroll to the examples to get the idea. We receive a string with dots on the left, dots on the right, and an operator in the middle, plus, minus, times, or divide. And then we return a string with the answer. So if it's 4 dots plus 10 dots, we give them 14. Or if it's 6 dots divided by 2 dots, we give them 3 dots. And this time I'm going to jump to the solutions first before writing it ourselves, because there's one thing I want to talk about, which is this guy. The first solution gets the 3 parts with a split. Great. Uses the len to find how many dots. Great. And then uses something I'm not going to use, which is eval. Okay, eval takes a string and then evaluates it as if it were a code expression. So if you eval 5 plus 3, it'll give you 8. You know, that kind of thing. And it's super powerful, but it's also super dangerous. If we eval stuff that we didn't make, right, the string comes from outside, then we could be running all kinds of crazy functions that we don't want to. There was a big scandal a year or two ago called log4j, where a Java logging module would take strings, or would take input and put it raw into a string, and then another part of a common library would just use those strings to run database lookups, and it would like download whatever you tell it to download, or it would run all kinds of things that could be dangerous. A lot of businesses had to like instantly shut down their servers and try to fix it with a lot of worry about how long has this been going on, how long have we had our vulnerability. So if you look at this second solution, absolute basic if else, where we just say if it's plus, we do the plus, if it's times, we do the times. And that would be great. I'm not going to do that because we kind of had one like that in our CodeWars exercises, where we made a little calculator and it would call the function. So I'm going to do something slightly different, but this is totally fine. I'm going to make a dictionary, and the dictionary is going to point to what function. So let's give it a shot. I have, no matter what approach, I have to start by getting our parts, making sure they're the right type, and so I'm going to use the same strategy the other guys did, which is the split method. And our things on the left and right, I'm just going to call them A and B. The thing in the middle, I'm going to call it operator. So I'm going to go A, operator, B equals text.split. This would be a really hard problem if it had multiple operations, like if it was this plus this minus something in parentheses times whatever. That would be a lot more complex, but this is guaranteed to be one operation, one thing on each side. And then this is not enough, because right now A is just a string. Like if I print A, it's just some dots. And there's not enough we can do with that, so we're going to turn them into integers. So I'm going to say A and B equal len of A and len of B. We don't need to actually count for the dot specifically, because that's all there's going to be. There's never going to be like a hello in the middle or something. And now is the hard part, finding the function that we're going to apply to A and B. I want to make, as I said earlier, I want to make a dictionary. It's not the only way, it's just something I like. So I'm going to do it up here. And I'm just going to call it func, because it's going to point us to the function. And that's a nice one-syllable abbreviation. So if there's a plus, it's going to do something. And if there's a minus, it's going to do something, etc. So what is it going to do? Well, it's going to need to point to a function. And I could define them outside, like def add AB return A plus B, and then I could define sub AB and define whatever. Since those are so short and so repetitive, I'm going to use a different method, which is a lambda. Whenever you need a function right here, right now, we don't need to name it. We don't need to have any fancy multi-line stuff. We just want a function right here. We go lambda, and then you name the two parts, like parameters and output. We say it takes AB, and it gives us A plus B. That's really nice and quick, and it fits in a small line just like we want it to. So that's going to be our pattern, and I'm going to do that 4 times with the other guys. Minus is going to give us A minus B, and times is going to give us A times B. And the next one, they say we're working in the world of integers, so we do the double slash to guarantee integers. And that sucks because it ruins our nice parallel spacing. You know how everything was lined up and now it's not? Well, too bad. I'm going to say we need to call the func based on what we look up in the dictionary. So whenever you do that, we're going to go func of operator and then A and B. Just like a normal function, you put the parameters right after it. Even though this is a result of a dictionary lookup, it's the same thing. And then we're not quite ready to return because that's going to give us a normal integer. Right? Let me print it just to show you what I'm talking about. If we print this, it's going to say, 20, but it should be dot 20 times. Or 2, but it should be a dot 2 times. Okay? So instead of that, we're going to return this whole thing times a dot. Now this line is a bit ugly. It's a bit dense because it's doing multiple things. It's looking up the function, running it, and multiplying by the dot. But since we've spent a few lines setting it up, we've got the dictionary, we've got everything, A and B are the right types, I feel okay with that complicated line because the names and the setup make it understandable. To me, if you wanted to, you could take an extra step and define the function and then run the function separately. Like we could say, action equals func of operator, and then we could go run action of AB, but I feel like that wouldn't help enough to justify the new name and everything. So if I run this, it's going to be great, and we're going to do the job. So basically what I've done is I've got this 3-line thing, just like the top guy had his 3-line thing, but now there's no danger of the eval. We can get some nasty, seditious input, and it's not going to mess us up. The absolute worst would be a key error. We look something up in the dictionary, and it's a key error. That's fine. It happens all the time. We could even avoid that with a try except or a .get or something, but it's okay here. We also avoid a bunch of repetition with the if-else stuff, and we don't have to say return 4 times. We don't have to have a sort of big expression 4 times. We just do these tiny ones, which I prefer. Now, another thing is some people have a dictionary right in here. They just define what's our last second lookup that we're going to do, where that avoids having to do the lambda because you're just actually returning the value and not the function that will be used to return the value. But I find it pretty hard to read if you have one line that's sticking out a lot longer than the others and it's making a new dictionary right in place. It's fine, it works, but I just like giving it a name. Now, if we scroll down, we're going to see pretty much the same type of stuff. This one is the if-else. It's a little harder to read because they don't give them names. They just have, index 1 or whatever. But it's fair enough. This one uses the eval, and they use the regular expression. to slightly simplify subbing the dots with numbers or whatever. This one realizes that, hey, there is an operator module that has add, sub, and mul, and the different things. So we can just point to those in our dictionary instead of defining them, which is certainly nice and readable. And I may have done that if I thought of it. Look at this one, though. Absolutely wild, and I would definitely not recommend it. They're doing try except 4 times. Like, hey, try to do adding if that's a thing you can do, if the split on plus actually succeeds and splits it into 3 things. Because if you try to return with the index, well, there's not going to be 3 things if you weren't able to split. And then you try minus, and then you try all the other ones. And what makes this crazy is that they're all going deeper and deeper. They're all dependent on each other, so that if the plus messes up, then none of them will ever work. And if the minus messes up, then none of them past it will ever work. And it feels like the opposite of nice, isolated, organized code, you know. This one, eval, this one, same thing. We're not really going to find too much to blow our minds afterwards. But if you scroll down long enough, you'll see a few that, you know, rearrange things a bit. The way I did it is not amazing. It does have a bit of repetition here with all the lambdas. So if you try something else, feel free. I'm not promoting mine as the absolute best. But I did like to introduce the eval thing, and I like to say what a lot of teachers will say and what a lot of books will say: never ever use it. It's super dangerous. Don't want to get in the habit. There you go.